Good evening, everyone. In this class, we will discuss the basics, fundamentals of permutation and combination. Right. Mm. So, try to understand this topic. Easy topic. You came across this topic in your school days as well as those who belongs to general mathematics. You can able to know about these topics. Right. Permutation and combination. Even in the CBSE, also 11th standard, you are containing. You are having this. That book contains permutation and a combination. This book gives you a simple way of learning the permutation and combination. So therefore, after this class, I will forward you this book also. You can use this book. This is the 11th standard Tamil Nadu old book. Not a new, it's a old book. So you can use this book. The first thing here is in order to find out the permutation, you need to know about the factorial. Right. Since the factorial concept very important, even in the number system also you are using the factorial. A factorial nothing but the continued product of first n natural numbers is called n factorial, denoted by n factorial. Right. Continued product. Some cases you can able to see in some books n factorial can be written as n into n minus 1 into n minus 2 into etc into, right. So therefore 3 into 2 into 1 up to 1. Some books provides you this one. Here this n factorial, right, you can write from 1 onwards up to n. So for example, here 5 factorial nothing but 1 into 2 into 3 into 4 into 5. You guys know about a 0 factorial. 0 factorial nothing but a 1. We will require 0 factorial in the later sections of this chapter. It does not make any sense to define it as a product of the integer from 1 to 0. So we define 0 factorial as a 1 factorial. How to get that 1 we will see shortly. First, you need to know the factorial, right. 0 factorial nothing but a 1, 1 factorial nothing but a 1, 2 factorial nothing but a 1 into 2, so that is nothing but 2, 3 factorial nothing but a 1 into 2 into 3, 6, so like that. 4 factorial nothing but a 1 into 2 into 3 into 4, 1 into 2 into 3 into 4, that is nothing but 24. 5 factorial nothing but a 1 into 2 into 3 into 4 into 5, this is nothing but a 120. Now you can able to see from the 5 factorial onwards your unit digit going to be the 0. From the 5 factorial onwards unit digit going to be the 0. So in the number system, these things I taught you for the batch already completed. For the batch yet to start, don't worry, I will discuss there also, learn here also, right. 5 factorial nothing but a 120. Because now try to understand, can we write that 6 factorial nothing but a 1 into 2 into 3 into 4 into 5 into 6. You know 1 into 5 factorial, that's sorry, 1 into 5 nothing but this can be written as a 5 factorial. So here we are writing as a 6, right. You know the value of 5 factorial 120, here 6. When unit digit nothing but is 0, if it is with multiplied with any other unit digit, surely you will be getting 0 only in the unit place, right. This concept also please remember. Now try to understand the 6 factorial I reduced as 6 into 5 factorial, because this 1 into 5 we can write it as a 5 factorial. So remaining 6 is there. That is why this property plays a vital role. n factorial nothing but n into n minus 1 factorial. Similar way, here 8 factorial. 8 factorial can be written as 8 into 7 factorial. Understood? Everyone up to this? Able to revise whatever the concept I am teaching you here? Because you learned in your 11th standard. Right? From Tamil Nadu, many of you came across this book itself. Now after 2019 only book changed. Okay. 2019 they changed that book, new book also. But this is the very good book. Next thing you need to learn about the fundamentals of counting. This is very important. In order to understand the basics of your permutation and the combination, you need to know about the fundamentals of counting. That is, there are two principles. That is a multiplication principle. Another one is the fundamental of addition. So there are two principles one has to understand before getting into the permutation and the combination. Right. So what do you mean by the fundamental principle of multiplication? Fundamental principle of multiplication. First, understand the fundamental principle of multiplication. There are two jobs. There are two jobs. It can be more than two jobs also, but understand the logic here. There are two jobs such that one of them can be completed in m ways and. So this is the keyword. In a multiplication principle, this is the keyword you need to take. And when it has been completed in any one of the m ways, there are two jobs such that one of them can be completed in m ways. The second job completed in n ways. The two jobs in succession can be completed in m into n ways. Let's see an example here. Along with the explanation, if you see, means that is a good one. See the example here. Don't see the explanation part, etc. This is not required. When you are understanding the example, that is not required. Listen. In a class of there are 15 boys and 20 girls. The teacher wants to select a boy. Here is the word and a girl to represent a class in a function, which means that the teacher wants to select a boy as well as the teacher wants to select a girl. In the situation, you need to use a multiplication principle. Let's see here. In how many ways can teacher make this selection? Here, the teacher is to perform a two jobs. One here is selecting a boy among the 15, selecting a girl among the 20 girls here. How many ways a teacher can? Listen carefully. There are 15 students, boys are there. From that boy, one can, no. So therefore here, the first one can be selected by, no, or else from the 15. The second one can be selected from the 20. So both the jobs has to be done. You have to check pick the boy as well as girl. So therefore, both the jobs has to be done in the succession. So therefore, 15 into 20 becomes 300. This is the fundamental principle of multiplication. Everyone understood? What is the fundamental principle of multiplication? Right. So we'll go slowly, no problem. This is a very important topic. See, beyond this also, competitive examination perspective, there are some other concept, some other shortcuts also there. But these are all very, very fundamental. One has to read this in order to get a basic concept of your permutation and combination. So your fundamental of principle of addition, please understand the keyword. There are two jobs such that can be performed independently. Here is the word independently. Right. There you used successive. Here we are using independently. Then either, this is the concept, either. For a multiplication, you are having and. For addition you are having either or. These are all keywords you have to take, right? So therefore this is the keyword one must have to take. Next, see here, same question. There are 20 boys and 10 girls. So this is the data provided, both the situation data same. See the question here. The teacher wants to select either a boy or a girl, so independently, or either or, right? But in the previous case, and both the things you have to, both the jobs has to be performed. Here either of the two jobs can be performed. Understand the concept. Represent the class, either boy can represent or girl can represent, but whereas in the previous case both has to be represent in a function. So here how many ways can a teacher can make this selection? 20, here 10. So therefore here either boy or girl, so therefore 20 plus 10, 30 ways. Principle of addition, either of the job can be performed means 20 plus 10, so 30 ways are there. Understood Appa? This concept, fundamental important notes etc you guys able to get. So like this I'll give you this PDF. You can also take this PDF, see the Tamil Nadu test book, very old book pa, before 8 years, before 8 years, but a very good book. Next, this is also simple question, yet concept is there. The room has 10 doors. In how many ways can a man enter the room through the one door and come out of a different door? Listen carefully. And which means that both the jobs he has to do here. He has to enter as well as he has to come out. But here the condition is different door. So 10 here. Right. So like that. Okay. Assume here 10. Suppose if he is entering here, to enter how many ways are there? To enter, 10 doors are there to enter. Suppose if he is entering here, he should not, or he will not come out of this, or he will not come through this way. Only enter is there. So door locked. So therefore to come out of that room, yes, 9. Both the jobs has to be performed, entering and coming out. So therefore multiplied. So therefore 90 ways. Understood up everyone? The fundamental counting very very important. Next, how many words with or without meaning of the three distinct letter, right, three distinct letter of the English alphabet are there? So three distinct, that's it. See, you do not have to read this kind of explanation. Understand my explanation, that is more than sufficient. There are total 26 alphabet. Three distinct means to fill this one you are having 26. One you wrote here, so therefore you are left with a 25. So distinct means different, so therefore you have 24. So therefore you have to multiply 26 into 25 into 24. So therefore this is nothing but 1560. Understood everyone? Right. Next year, how many 3-digit number can be performed? How many 3-digit number can be 3-digit numbers can be formed? How many 3-digit numbers can be formed by using digit 1 2 3 4 5? Digit 1 2 3 4 5. 3-digit, no? Here nowhere mentioned as a repetition or not, no, non-repetition etc. The digits are repeated, not repeated. These things and all not provided. In such a situation, understand it's a default that a repetition of the digit is allowed. Right. So when it is allowed, 3-digit number, no. So therefore here 5 ways are there, here 5 ways are there, here 5 ways are there. all the jobs has to be performed, so therefore you have to multiply this. So 125. Understood everyone? Getting? Okay, next. Suppose if the question here is, listen here itself, if the question here is how many distinct, please understand, if the question is how many distinct 3-digit number can be formed in such a situation, 5 4 3. Understood everyone? 20 into 3 60. So this is also possible if the question is distinct. Shall I proceed further? Next. See the question pa. There are 6 multiple choice question in an examination. There are 6 multiple choice question in an examination. How many sequence of answers are possible? If first 3 questions have 4 choice, next 3 have 5 choice. So therefore 6th multiple here. First 3 have the 4 choices. Therefore 4 4 4. Next 3 3 3 3. That's it. Sorry. Next 3 have the 5 each. 5 means 5 5 5. 5 each. So therefore 4 into 4 into, because all the job has to be performed here. 4 into 4 into 4 into 5 into 5 into 5, 8000. Understood? Next. How many 3-digit number greater than 6000 can be found by using the digit? Very good question. Listen carefully. Greater than, simple question, yet a good question. Greater than 600 means, greater than 600 means 7 comes, 6 also comes, 8 also comes. Because by using 4 5 6 7 8, so therefore to fill this one you are having 3 possible. Here anything possible. Here also anything possible, since the question contains can be formed by using the digit, nowhere mentioned as a distinct etc. So therefore to fill the 100 place you are having 3 ways. Why 3 ways? Because greater than 600 means 601 onwards. So therefore 100 place contains 6 possible, 700 series 7 possible, 800 series 8 possible. So therefore 3 ways here. Here are any ways. So 3 into 5 into 5 becomes 75. Understood everyone? Shall I move to the rest? Okay. How many numbers divisible by 5 lying between 5000 and the 6000 can be formed using the digit? So now listen carefully. Between, so now the constraint plays here. All are 4-digit number. Please understand, all are 4-digit number. The first place you need to fill where there is a more constraint, or when it is necessary to fill that place, you have to fill that one, right? Now try to understand. Divisible by 5 means that this place surely 5, no other possible here. 5 6 7 8 9, only one possible here. So therefore 5 alone comes here, so therefore only one possible. Now understand, between 5000 and 6000 means surely start here with 5001 up to 5999. So therefore the 1000 place also 5 here, only one possible here. To fill the rest of the things here, 5 possibles here, here 5 possible, because all the 5 digit can be placed here. All the 5 digit can come here. So therefore 1 into 5 into 5 into 1 into 5, 5 into 1. So answer is 25. Everyone understood this one? Clear, right? So let me move on to the next. This is fundamentals, no counting principle pa. Next here. Here clearly stated here, repetition of the digit allowed, repetition of the digit is not allowed, etc. How many 3-digit numbers can be formed by using the digit 4, 5, 6, 7, 8, 9. If the repetition of the digit are not allowed. How many 3-digit odd numbers? 3-digit, right? Place here. This is a 3-digit. Odd number means the unit place must contain a odd. So here 4, 5, 6, 7, 8, 9. What are all possible for odd in the unit place? 5, 7, 9 comes in the unit place. So therefore 3 possible ways to fill this one. Unit place can be filled. 3 possible ways. One comes here. Listen carefully. One comes here. Anyone. From these 3, anyone comes here. So therefore, the rest of the places can be filled. Suppose if you are filling 5 here in the unit place, the 10th place can be filled in 5 ways. Suppose if you are filling your anyone, to fill the 100th place you are having 4 ways. So therefore 4 into 5 into 3, 60. Understood? When the repetition is not allowed. Suppose when the repetition is allowed, here 5, here 5. So therefore 5 into 5 into 3, 75. Understood? Difference between the repetition is allowed and the repetition is not allowed. Getting? Okay, fine. Why 60 character? What is the question here? Repetition of the digit is allowed. Total 6 pa here. Sorry pa. 6 means 6. Yes. Yes pa. Total 6 means 6. 6 into 6, 36. 36 into 3, 108. Understood pa everyone? I was thinking here as a 5. No. 6. Next pa. You try this. Right? Must try this question. This question you must try. Because this kind of model was there in your previous year UPSC. 7 flag of different colors. How many different signals can be generated if a signal requires the use of 2 flags, one below other? You guys answer this question. Try. 7 different flags. Different colors. Right. You try. Different colors. 2 different, right? The first one, listen. One below other. So the first one can be filled here with 7 possible ways. The second one, suppose if you are using one color, you should not use that one. To fill this one, you are having 6. So therefore 7 into 6, 42. Understood? Understood? Or in a simple manner, listen, if you know the permutation combination, permutation you can use. It's arrangement only. So therefore 7p2. If you use the 7p2, it's an easy one. 7p2, how to write means 7 into 6. That's it. From 7 you have to use 2 places. From 7. So 1, 2. 2 places. Shortly I will give you an introduction about permutation. There I will explain again this one. Why 7p2 can be written as 7 into 6. Right? Next. Getting? See, without this permutation combination also I explained there. How this one. First one can be filled with 7. Simple arrangement you can use. Shall I move to the next? Okay. Remaining and all, okay, not required. Even if you are not practicing, also no issues here. Concept you have to understand. The concept of permutation very important. The concept of permutation very important. The word permutation means arrangement, as I mentioned in the arrangement. So here in arrangement, please understand, in arrangement order is very important. Order is important. If order change, then your arrangement also changes. That is very important. Note you have to take. In your arrangement, order is important. See here. For example, A, B, C. Suppose we are arrange them two at a time. So therefore A, B, B, A, B, C, C, A, and A, C. So therefore, three things you are taking, arranging two at a time. Listen, three things taking, arranging two at a time. 3p2. From 3 you have to write two places. 3 into 2. So therefore 6. That's it. In a simple manner you can write. This and all manual calculation if you are doing is a lengthy one. Simple way you can write. That is why the definition of a permutation says the number of arrangement that can be made out of n things. So n here is 3 here. Taking r at a time. That r here is nothing but a 2. 2 at a time. Is the number of permutation of n things taken r at a time. Even if you don't know that definition thoroughly, simply you learn n things taking r at a time. That is more than sufficient. N things no taking r at a time. So that alone, if you remember, that is also good. Now NPR, this is nothing but your permutation. NPR is equal to n factorial by n minus r factorial. This is a very important formula one has to remember. NPR is equal to n factorial by n minus r factorial. Just now we have done in the previous case 7p2. How we got is 42. If you apply this formula here, 7 factorial by 7 minus 5 factorial. 7 minus 2 factorial becomes a 5 factorial. If you write a numerator, it becomes 1 into 2 into 3 into 4 into 5 into 6 into 7. Right, this is 5 factorial. You can write it as a 1 into 2 into 4 into 5, 4 into 5. So that 5 factorial getting cancelled here. See here what you are getting here, 6 into 7. That is 7 into 6. Getting everyone? In simple manner, remember in a simple manner. Listen, remember in a simple manner. How? Suppose if 8p3 means, listen, from 8 you have to move 3 places. 8 into 7 into 6. 3 places, not up to 3. You have to move up to 3 places only. Guys, getting? Not up to 3. Here up to 3 places. Suppose 9p2 means 9 into 8. Getting? This is the shortcut. Short way. Or else you have to use the formula. Don't use formula all the cases. If you understood means I will move on further. Okay, fine. SEPA here, example. Here note is important. As I mentioned there, in a permutation, order of an arrangement is taken into account. When the order change, different permutation obtain. That is why I said in a permutation, order plays a very crucial role. Order plays a crucial role. See here, the permutation. See, write down all the permutation of your vowels A, E, I, O, U in English alphabet, taking 3 at a time, starting with the E. Starting with the E. Right, starting with the E. Now, if you simply see here 5 here, some people will use like this 5p3. Suppose if you are using that is wrong, because if you see this one, it becomes what? 60. Right, here If the question is write on all the permutation of the vowels A, E, I, O in English alphabet taking 3 at a time, then that is nothing but a 60. But here the question says starting with E, right? Right. So E fixed here. Listen, very simple way. E fixed here. So therefore E fixed. The remaining 4 is there, no? So from that remaining 4 only you have to arrange that one. 4P2. E fixed there. Remaining here is 4. You have to take 3 already done. 3 E is fixed here. So that two places can be filled. Listen carefully. That E fixed here. That two places can be filled in how many ways? Total 4 here. So this can be filled here 4. This can be filled here 3. So therefore, here this is to fill this E only 1. So here 4, here 3. So therefore total. If you are writing this kind of things, it's a lengthy and you will make a mistake. The question is how many possible. That alone will be there in the question. Answer is 12. Getting how 12, guys? The fundamentals you have to remember. E to fill that other two boxes 4P2. If you remember that 4P2, that is also good. 4 into 3, that's it. Or else this kind of counting also you can do. E can be filled in only one ways. The next place can be filled in 4 ways. The next place can be filled in 3 ways. That's it. Understood? So therefore 12. So let's move to the next. Right. These and all not required. As I mentioned, a formula. To derive the formula only, they are writing this kind of explanations. Not required. This alone you take. Already I explained. NPR is equal to n factorial by n minus r the factorial. Right? Shall I move to the next? Okay. The property plays a very vital role. NPN is equal to n factorial. Suppose they will give you 5p5. 5p5 can be written as what? 5 factorial. Why? Let's see here. Let's see here. 5p5 can be written as what? 5 factorial by n minus r factorial. 5 minus 5 factorial, 0 factorial. What is the value of 0 factorial? 1. So therefore 5 factorial itself. So that is why 5p 5 nothing but a 5 factorial. In generally you can write npn is equal to n factorial. Let's see why that a 0 factorial is equal to 1. See here. npr. So you are substituting r is equal to n. Then it becomes 0 factorial. npn is equal to n factorial. Here. Right. Since npn is equal to n factorial, we are writing the LHS as a n factorial. Then cross multiply. 0 factorial nothing but n factorial by n factorial getting cancelled, which is equal to 1. So that is the procedure to find out the 0 factorial. Guys, getting? Some of you may have a doubt like why 0 factorial is equal to 1. So this is the procedure to find out the next. Shall I move to the next? Right. These are all not required. When it is necessary to understand, let me tell you that. So here this is important. Simple questions are important. In how many ways can 5 children stand in a queue? 5 children stand in a queue. So therefore 5 children can stand in a queue. Right. Here first place 5, next here 4, next 3, next 2, 1. So we have to multiply here. All the jobs can be done. So therefore 1 into 2 into 3 into 5 nothing but a 5 factorial, 5 factorial nothing but a 120. Getting? Or there are 5 places, all the people has to placed in a queue. So therefore 5p5. What is 5p5? npn is nothing but a n factorial. So 5 factorial nothing but a what? 120. In this way also you can do, or else the diagrammatic way also you can do. Understood, everyone? Next, this kind of question already there in your UPSC pa. This kind of question already there in your UPSC PYQ. And how many different signals can be made hoisting 6 different color flags, one above the other, when any number of them may be hoisted at one time. Any number can be hoisted at one time. This can be a direct question to your or in your UPSC examination. This question possible pa. This question possible. A direct one. You please check the page number 82. Take this question and make it in your notes. This can be a direct question if the questions of such. How many different signal can be made hoisted by hoisting 6 different color flag, one above. So this is the concept. To fill this one, 6 year 5 year 4 year 3 year 2 year 1. Understood, right? Now try to understand. So what do you need to do here? This is a very important question pa. What do you need to do here? Here 6p1, because the question clearly says here the signal can be made using at a time 1 or 2, 3, 4 or 5 or 6 flags, right? The total number of signals when R flags are used at a time from 6 flags is equal to the number of arrangement, is equal to the number of arrangement. So here it question says minimum, the question says here is minimum 1. So therefore 6p1 plus 6p2, 6p3, 6p4, 6p5, 6c6, right? These are all possible. 6p1 can be written as a 6, 6p2 can be written as 6 into 5, 6p3 can be written as 6 into 5 into 4, 6p4 can be written as, from 6 you have to move the 4 places, 6p5 nothing but you have to move 5 places, 6 means you have to move 6 places. At least remember the answer 1956. Important question. Okay, shall I move to the next? Next, this one. So now let me show you the question again. See the question carefully. You mark these things in your notes, page number 82. See the question carefully. How many different signal can be made by hoisting 6 differently colored flag, one above the other, right? Where this is the statement bar. Any number of them may be hoisted at one time. Any number, which means that only one can be hoisted. From the 6, 2 can be hoisted. From the 6, 3 can be hoisted. Then 4 can be. Next 5 can be. Understood? Next 6 can be. So to fill this one, only one. So therefore you are having 6. So therefore 6p1. 2 flags. So therefore 6p2. 3 flags. 6p3. 4 flags. 6p4. 5 flags. 6p5. 6 flag. 6c6. Understood? All the jobs performed independently. When all the jobs performed independently, what you have to do? You have to do a plus. Yes, got it. Why? This is the important why. Why important? When any number of them may be hoisted That is why. See, your option may contain 720 also. Possible to make a mistake. But here you have to be very careful. Any number of them may be used at one time means what? 1 possible, 2 possible, 3 possible, 4 possible, 5 possible, 6 possible. Got it? Everyone. Shall I move to the next? Very important part. This book is the very important book to learn the fundamentals of your permutation combination. Find the number of 4 different letters with or without meaning that can be formed from the letter of the word number. Total how many? 6 letters. 4 letters you have to write it. Therefore 6p4. That's it. 6p4 nothing but 6 into 5 into 4 into 3 is 360. Got it? Right. Now this is the very important question. This example 3.24 very important. Your UPSC question is there based on this. UPSC direct question. I think to 2015. I think so. 2015 or 2017 direct question. This one direct question. But that question nothing but a 2 brother, 2 sister. That question related to 2 brother, 2 sister. Here 4 brother, 3 sister. But the same concept. You may get a question of this one directly. 4 brother, 3 sister is to be arranged in a row for a photograph. In how many ways can they be seated? If all the sisters sit together. Sit together. Listen carefully. 4 brother, 3 sister. All the sisters sit together means, now try to understand. Totally how many people are there? Totally 7. Right. Now try to understand here. The 4 boys can be seated in a 4 factorial ways. Right. Here 3 sister can be seated in 3 factorial ways. That is a general one. General one. Not with respect to this question. Generally I am saying. Now here all the sister sitting together means what you need to do here is 4 brothers you have to write here. B1, B2, B3, B4. All the sisters, that is S1 and S2, S3, all of them can be treated as a single unit. You have to treat them as a single unit. When they are sitting together, you have to treat them as a single unit. So, if you are treating as a single unit, how many people are there totally? 5 people only. So, these 5 people can be arranged in a 5 factorial ways. These 3 sisters can be arranged in a 3 factorial ways. Why? This S1, S2, S3 possible. Next S1, S3, S2 possible. S2, S1, S3 possible. S2, S3, S1 possible. Like that. Right? That is why here 3 factorial. 6 ways that sisters, 3 sisters can be arranged. Understood everyone? That is why the answer here is 5 factorial into 3 factorial. 5 factorial 120, 3 factorial 6. Answer here is 720. Direct question possible. Loan here. Direct one possible. Understood? If you want, you can take a screenshot also. This question possible. When a UPSC examiner wishes to give you a very basic concept like a arrangement, this and all possible because 2015 model is there. When I teach you this time is there, I will teach you the PVQ or will give you a link of PVQs. Listen, will give you a permutation combination PVQ discussion link in your groups, right? Already discussed. Please kindly follow. Now, all the system not together. Please understand. All the system not together means first step. What you need to do is you find the total number of factorial. Total arrangement you have to do. Total how many people are there? 7 people are there. 4 boys, 3 sisters. Total you have to find out the total arrangement possible. 7 factorial. This 7 factorial nothing but a 5040. 1 into 2 into 3 into 4 into 5 into 6 into 7. 6 factorial nothing but 120, 127 nothing but a 5040. This is the step. Yes, this question was there. Like all the sisters are not together. Then what is the answer? 12 was the answer for that question. I still remember. 2 boys, 2 sisters, brothers, 2 sisters. Find how many ways they can be seated if all the sisters are not together. That question was there. Answer was 12 for this one. Yesterday only I taught this in the CSAT. Not this book, that question. Still I remember that one. Right. Listen. Next. So this is the total. From the total, what you need to do? You have to subtract all the possible ways of seating together. What is the possible way of seating together? 720. Subtract that one. Answer is 4320. This is the possible of not seating together. Now you guys try that question. 2 brother, 2 sister. What is the possible? How many ways they can be seated if all the sisters are not together? You try to answer now. Check whether you are getting a 12 or not. 2 brother and 2 sister. Not sitting together means what you need to do, pa? First step, you have to find out the total arrangement. Guys, wait. Screen visible? Yes, visible. When I am writing and erasing, it's blinking. Here. Simple. First thing is 4 people can be arranged in a 4 factorial ways. So that is nothing but 24. Understood. So now seating together. Please mute ma. Mute ma. Right. Now here. Total 4 people. 2 brother. That 2 sisters must be considered as a single unit. So therefore 3 people. Right. Here 3 people. Understood everyone? These 3 people can be seated in a 3 factorial ways. That 2 sisters can be seated in a 2 factorial ways. Here 6 into 2. This is nothing but 12. This 12 is nothing but a seating together. But the question is not seating together. So therefore from the total you have to subtract a seating together. 24 minus 12, answer is 12. Understood? This is a UPSC question. This is the exact question provided there. Understood everyone? From where the concepts are evolving from the very basic books, your school books, fundamental. They are giving you questions. Next. These are all possible. Permutation of object, not all distinct. Permutation of object, not all distinct. Not all distinct means some repetitions will be there. In the situation, example itself you see here. How many permutation of the letter of the word apple are there? Apple are there. Total 5. So therefore 5 factorial. Next, repetition is there means you have to divide in the denominator. P repeats twice. 2 factorial. That's it. You do not have to write 1 factorial, 1 factorial. These are not required. Repetition is there means you have to place it in the denominator. 5 factorial 120. Here 260. Guys getting? How many permutations of the letter of the word? They will not mention this permutation. Because permutation means directly you guys will use it. They will mention how many ways of in how many ways the letter of the word apple are arranged. In how many possible ways. So like that they will give you. Understood? Next, see here. In how many numbers here? How many numbers can be formed with the digit? So that the odd digit always occupies the odd place. Odd digit occupies always odd place. How many odd are there totally? 4 odd there. 4 odd. 4 odd places. So therefore 4 factorial. 1 repeated twice. 2 repeated twice. So therefore in the denominator 2 factorial, 2 factorial. Understood why they wrote 2 factorial, 2 factorial. Next, the remaining 3 even digit can be arranged in 3 factorial into 2 factorial. Why? 3 nothing but a 2 2 4. 2 repeated twice, that is why here 2 factorial. Understood, everyone? Here you have to find out the how many numbers can be found with this digit, which means you are taking all the digits here. So therefore this is nothing but you have to multiply. That 2 jobs has to be performed. That is why they are multiplying here. So here 6, here 3, total 18. Getting? Understood? Some of the SSC examination, this kind of questions are directly possible. Mathematics. Total 11. So therefore 11 factorial. M repeated twice, A repeated twice, 3 repeated twice. Some people will see this also, Mississippi, like that arrangement. So one concept, permutation, when the object, permutation of object, not all distinct. Topic by topic you have to learn, not all distinct. Next, permutation when object can repeat. Can repeat. The question says can repeat. In how many ways? Listen carefully. In how many ways? Four distinct apple can be distributed. Sorry, let me take a 5. 5 distinct apple can be distributed among 4 boys. 5 distinct apple can be distributed among 4 boys. In the situation, listen carefully. Try to understand. This is the concept. The permutation of n different things, nothing but the distinct, taken or at a time, when each may be repeated any number of times, in each arrangement is n power r. Here, this is nothing but what? 4 power 5 for this question. Why? All the 5 distinct apple can goes to the same boy, that is B1. All the 5 distinct apple goes to the B2. All the 5 distinct apple goes to the B3. All the distinct apple go to the B4. That is why here 4 power 5. According to this question, 4 power 5. But this method, lengthy method, listen carefully. For this question, in how many ways 2 different balls can be distributed among 3 boxes? What do you have to write? N power r. What is n here? Which is the n here? 2 different balls, that is the n here. Right? Distributed among 3 boxes. Then n power r nothing but 3 power 2. Can you able to relate this one? Anybody having a doubt here? Taking 2 at a time, distributed among the 3 boxes. So this is the question already there in your some of the competitive examination. 5 distinct apple can be distributed among 4 boys. This question was there in some of the competitive examination. That is why I am giving this one 4 power 5. Okay. Next, here, in how many ways 5 different balls can be distributed among 3 boxes? 5 different to the 3. So therefore 3 power 5. Understood, everyone? Next question important part. This is 3.29 important. Example 3.29 important part. This is important question, important question, important question. Sometimes possible to repeat. Read here. In how many ways can your 3 prizes can be distributed among 4 boys? When no boy get more than 1 prize. A boy may get any number of prize. So any number of prize means what? Here directly you can write here 4 power 3. For this question directly you can write 4 power 3, 64. But first question you have to be very careful. No boys get more than 1 prize means what? All the boys getting which one? 1. So therefore 4p3. What is 4 by 3? 4 into 3 into 2. So therefore 24. Guys, getting the first question. The now total number of A's, the number of arrangement of 4 taken 3 at a time. This is the first one. Guys, getting this one. Second one, over. Because a boy may get any number of prizes. So therefore 4 by 3. No boys get all the prizes means what you have to do? From the total you have to subtract. See here. From the total you have to subtract. Since any one of the 4 boys get all the prizes, so therefore you have to subtract here. Understood? 60. Next, circular permutation, important part. Just you can have two things related to the circular permutation. One here is the number of circular permutation of n different objects is n minus 1 factor. This one you have to take in a circular permutation. In how many ways? In how many ways? 6 different people can be arranged in a circle. They'll put up a question. In how many ways? In how many number of ways? 6 different persons can be arranged in a circle. 6 different. So therefore 6 minus 1 factorial. Understood, everyone? Question is there like this. And one more concept related to the circular permutation, understand here. When the number of things from the right and from the left are same, then you have to use a different one. For example, bead concept. Bead making, no, chain, bead, that kind of concept you can diffuse here. See here, I think this one is that. Yes, this one. This one. Difference between the clockwise and anti-clockwise arrangement. When there is a no difference, see here, the number of circular permutation of n things in which clockwise and anti-clockwise arrangement gives rise to the different permutation. Different permutation means n minus 1. But if it is not gives you different means bead concept you can see here. If there are n things, the direction is not taken into the consideration. Even if you see the clockwise and if you see the anti-clockwise, it look like the same. In the situation, the number of circular permutation is n minus 1 factorial by 2. N minus 1 factorial by 2. This is a very important. Let me see here. Let me check the question. See here. In how many ways 10% can be arranged in a circle? Circle means what? N minus 1 factorial. In a line means 10pp. 10p, 10. Understood, Appa? Line means what? 10 factorial ways. In a box way also you can do. To fill the first one, 10. To fill that one, 9. Next, 8, 7, like that. Directly you can write 10 things. No? Taking 10 at a time. So therefore 10p10. In a circular way means n minus 1 factorial because changes here. This is related to the person. Alright. But if you see this one, in how many ways 7 identical beads strung in a ring. Identical. Identical means what? Even if you place them in your clockwise or else anti-clockwise, it will not give you a difference. In such a situation, you can use n minus 1 factorial by 2. So therefore 7 minus 1, 6 factorial by 2. 6 factorial nothing but a 720. 720 by 2 nothing but a 360. Understood, Appa? Everyone? Hmm? Right. Now this is the very important question, Pa. This is a very important question. This example 3.32, very important question. This example 3.32, very important question. In how many ways 5 gentlemen and 5 ladies sit together at a round table so that the no 2 ladies may be together? Very important question. Possible, Pa? Possible. This one is possible to come in your examination. Listen, first of all, check here that 5 gentlemen can be arranged in a circle, nothing but a 5 minus 1, 4 factorial ways. Gentlemen's. Here ladies, no, them only, there only. See here, you have to be focused in a very simple manner. The ladies may be arranged among themselves in a 5 factorial ways. Why? Why you are taking gents as a 5 minus 1? Anyone can say? Where the constraint provided here? That is right. Round table means that is a circular one. Yes, first thing you have to check here where the constraint places here. The constraint places with the ladies. So when there is no constraint with the rest of the things, that can be arranged in a circle with n minus 1 factorial ways. When there is a constraint, you have to be very careful. That two ladies know. So in such a situation, what do you need to do here? The ladies can be arranged in themselves in a 5 factorial ways. So therefore 4 factorial into 5 factorial 2880. Understood, everyone? Next bar. This garland question also you can take care. Find the number of ways in which 8 different flowers can be strung to form a garland. Listen. Strung to form a garland. Right. So that 4 particular flowers are never separated. So never separated means what? They are together. So first of all understand here 8 different flowers, 4. From these 4 you are guys getting this one. 4 never together. So therefore what do you need to do here? 4 particular flowers as a one unit. As I mentioned there now 1 unit. So therefore total 8. Here 4. Here that remaining 4 can be split as a 1 unit. Total how many? 5. That 5 factorial can be placed in a circle means n minus. So that 5 can be placed in a circle means n minus 1 factorial. That is why here 4 factorial. Right? These 4 people can be seated in a 4 factorial ways. That is why here 4 factorial ways. Guys getting? Hmm? Never separated means what? Together. The together concept. We don't know that girls together, not together. That concept. Suppose if I put a question here, never together. Suppose what will you do? So that the 4 particular flowers are never together. In the situation, what will you give the answer? Please give the answer. 4 particular flowers are never together. Then how will you answer? Please try. Total minus 1. Total minus what? Together, appa. Total minus together. So what is the total, pa? 8 factorial. Understood? Minus together. Together nothing but what? Together nothing but 5 factorial into 4 factorial. Understood? Hmm? But because coming together means you have to treat them as a single unit. Understood? So that is why here 5 factorial, that 4 people can come together, that is a 4 factorial. So therefore 8 factorial minus 5 factorial into 4 factorial. Guys, getting? Understanding concept very very important for permutation combination. Now we have completed that permutation. Now answer the 16th question. How many ways can a garland of 20 similar flowers are made? 20 similar flowers are made. 20 similar flowers. Why, sir? Quickly, pa. Simple question, taking time. How many ways can a garland of 20 similar flowers? Oh, pa, 20. N minus 1 factorial by 2. 19 factorial by 2. 19 factorial by 2. How 20, pa? They were the understood mute ma.
Let's do this.
19 factorial by 2 only, right? Others getting right, because flower, similar flower means what? Even if you see in the clockwise and anti-clockwise, both look same here. Beat concept. Then n minus 1 factorial by 2. Don't do a mistake. Now, when you say 8 two students can be seated in a line or circle. Line means what? 8 students. 8p8. Circle means what? Circle means what? Circle means 8 minus 1 factorial. Understood? For 15th question, 8p8, 8 minus 1 factorial. Here 16th question, n minus 1 by 2 factorial. So now, shall we complete the session or shall I proceed to the combination? If I proceed the combination, I require another 1 hour. What shall I do? Anything fine for me? You guys have to say.
Tomorrow, sir.
Tomorrow. Okay, right. But the fundamentals getting related to the permutation, all the fundamentals related to the permutation over. Some other competitive level concept is there. But this is the fundamental. To attain that competition level, shortcut, etc., that I'll give you in the subsequent classes. The first, you need to learn this basics first of all. Understood? Learn these fundamentals. After the fundamentals, you move on gradually. Competitive kind of questions. I'll give you all the competitive kind of questions. Next 2 to 3 days, surely we are going to discuss a combination. It may go up to Wednesday also, 4 classes also, no problem. But you need to be very strong in the permutation combination. This year, possible to get a question, at least 1 or 2 questions possible. 2022, no, in 2023, there were lot of questions related to the permutation combination. But 2024, no question. 2025, no question. So therefore, possible to get a question in the 2026. Be careful, be careful. Okay, so combination concept, let me teach you tomorrow everything like this one. Let me explain slowly. And if we are if we able to complete combination in an hour, Half an hour I will give you a introduction related to the probability. Understood? So that a problem discussion can be done along with the permutation combination probability, because the probability concept also need a permutation combination. So you have to cooperate. Okay, fine. Let's complete today's session. Thank you all. Have a good day.